All right. Thank you, everybody, for being here. I think we will get started now. I think it's 11:30. I am very excited to be here with you all to talk about agents, and specifically building agents with Claude in Databricks. So just a quick introduction to myself. I'm a member of technical staff at Anthropic. I work in our Applied AI organization. You can think of our Applied AI team as sitting at the intersection of product research and go-to-market, where I spend about 80% of my time helping large strategic customers build products with our models, both internal things to help streamline operations, and then also external-facing products that they deploy to their users. The other 20% of our time we spend contributing back to various internal product and research initiatives, doing some things that look a little bit like DevRel as well, coming to conferences like this and talking, making developer cookbooks, and things like that. It's a fun role, and the only subtle plug I'll have for you throughout this entire presentation is if you are an AI engineer and you want to work with customers to some capacity, we are hiring a lot of folks in this organization, so if you're interested, please consider applying or come find me after this talk and we can chat. So in terms of today's agenda, some of this will be general theory. How do we at Anthropic think about agents? How are we thinking about training our models to be better at doing agentic things? And then we'll get into some practical advice, things that me and my team have learned about building agents. And then I'll also briefly go through how to get started with agents in Databricks as well. They made it pretty easy to get started deploying agents, interfacing with tools and Unity Catalog and things like that. And we'll make sure we cover all of that stuff. But to kind of frame this conversation, again, this is the theory part, then we'll get into practice in a few minutes. But we like to talk internally about what Claude's role is in our lives. We obviously use these models internally like crazy. We're keeping very close tabs on what Claude is capable of doing and not capable of doing and where we think things are going to go. And I'd say if you rewind the clock about a year to mid-2024, even like early 2024, late 2023, I think these models were fundamentally just assistants, right? They could perform back office operations for you with classification tasks or do metadata extraction or sentiment analysis. That's been solved for a while, I think. They can also summarize things for you. They can be good chat assistants. They can be good autocomplete models in IDEs. And they can do some higher level tasks. As we got into late 2024 and now into 2025, models have gotten more intelligent, but not just more intelligent in terms of being able to solve complicated math problems or knowing more things about the world, but they're more intelligent in the sense that they can actually take on more work for you. The kind of work that would have taken you a while to do. And that's I think where we are now. We have lots of anecdotes and stories that we've heard that we can also tell internally about things that we've done within Anthropic that really show Claude doing things, especially in the coding domain, that would normally take a human 4, 5, 6+ hours, right? So we're quite excited about where we are today, but this is going to continue to evolve, right? So in 2027 and beyond, we think Claude's going to not only be able to collaborate with you and take on hours of work, but also pioneer and start coming up with new ideas and executing them on their own. We're a little bit away from that, but I do think that this is the curve, and you can see this too in third-party benchmarks, right? So this is from Meter. This is a little bit outdated because Sonnet 3.7 is the model here, not Sonnet 4 or Opus 4. But you can see here that the length of tasks that an AI can do is doubling every 7 months or so. So if we play this out, this means that in the fall, we'll have models that can take on 2 hours worth of tasks for you. And then at the end of 2026, we're looking at like a full workday's worth of tasks. The core thing the model is doing in these cases, though, is fundamentally operating in a kind of agent loop, right? So models that are able to take on tasks for you that would require them to work for hours, that architecture is usually always going to look like an agent. I'll get into exactly what those architectures look like in a little bit, but this is something to just continue to keep tabs on, right? We are continuing to be on this new exponential just in relation to how long a task a model can do for you. We are very focused at Anthropic on building models that are really good at being agents, right? So Claude 4, Opus, and Sonnet, we believe are the best models in the world at doing agentic work, right? This is, I think, commonly known in the coding domain. Claude's very good as a coding model. The whole vibe coding revolution is in large part powered by Claude, but this extends to beyond the coding domain as well into other things. So TauBench is another benchmark that measures just general agentic performance in a customer support domain, where in this benchmark, you give the model access to a series of tools and then policies about how to use those tools, and we just check whether or not the model successfully calls those tools according to the policies and gets the task done on behalf of the human, right? And you can see there that like in the mid-2024 days, the highest performing model on TabBench was in like the low 60% range. Now we're nearing the 80+% range on retail, right? So there's been a lot of growth here. And again, this doesn't just apply to coding. This applies to any domain where you're going to give the model access to a series of tools and then allow it to run in a loop in an agentic workflow until the model decides that it's done. So if we think about more into the practical side here, we put out this blog post in December of 2024 that we're actually going to make, I think, a part 2 on pretty soon that is all about building effective agents, right? So this is our point of view on what an agent is, how an agent is different from a workflow or an augmented LLM. I want to cover some of those ideas here just to make sure that we're speaking a common language, and then we'll get into some of the practical bits about actually building these things. So we differentiate between just like a basic augmented LLM system, a workflow, and a true agent, right? And I'll walk through each of these levels here. Each of them are super valid and have their own use cases, right? So at the heart of every successful agent or workflow is the augmented LLM. So this is effectively a building block that can be composed into other architectures as well. But this also might be sufficient in and of itself. If you have a classification task to do, you probably don't need a complicated workflow or an agent to do that task. You can just maybe hook the model up to a retrieval system if you need it. Maybe there's a tool you need to use. But fundamentally, this is just basic LLM input-output, right? Some of the other building blocks here that you can optionally use are retrieval systems, right? So you could use the RAG circa 2023, where you just embed the user input, do a semantic search, and then load in some documents deterministically. You can also give the model access to tools. Maybe there's retrieval tools. Maybe there's other tools, right? And then maybe you have some concept of memory as well that the model can read and write to. But this is fundamentally like the basic building block that makes up everything else. And again, it might be sufficient in and of itself for a lot of use cases. A level up from that, for more complex use cases, are workflows. So these are incredibly common. A lot of people, when they talk about agents they're building, if you really peek under the hood, most of what is happening is fundamentally a workflow. And you can think of a workflow as just chaining prompts together, right? There are some patterns that are tried and true that are deployed everywhere. This router pattern that you see here in the top left-hand side of your screen is extremely common everywhere. Maybe you have a classification step and then a series of prompts that you route the request to. That works extremely well. There are other ones as well around parallelization that is often interesting for research or analysis tasks. There's many others, right? There's this orchestrated worker pattern. Maybe you have a planner. Maybe you have an aggregation step on the back half, right? This can take many, many different forms, right? This is really encompassing any DAG of prompts, right? There are plenty of frameworks that make it easy to build these. LangGraph is one of them. You can do this using some of the Databricks AI framework tools with Mosaic. And fundamentally, this is just you defining the code path and allowing the model to pass through that code path. An example of this in production is something like a customer support workflow, right? In customer support, I'd say most of the implementations are workflow-based. There's reasons for that. In many cases, maybe you need just really high reliability. You need to define exactly what the state of the system is at any given point in time because that reliability is so important to you. And this works, right? A lot of the customer support implementations that I've seen work look a little bit like this, right? There is a router step on the front half. Maybe you classify the query, and you do different things based on the classification. In the simple case, maybe your only classification is, let's try to answer it with the model or escalate to a human. That's common, but you also might have fallbacks to ask clarifying questions or things like that. And then maybe at the end, on the right-hand side of the screen, you might have a guardrail where if the model says, yes, we can show this to the user, you show it to the user. If it says no, maybe you retry or you escalate to a human, right? Again, this is just one example. This can take many forms, but in customer support, I'd say these have product market fit for sure. Agents, on the other hand, are systems where models can sort of autonomously plan and execute their own complicated tasks, right? This is where maybe you have more open-ended problems. Maybe the steps to follow are less predictable, and they don't really lend themselves as well to some kind of predefined code path or DAG of prompts. This is where agents come in. And if you look at the architecture on the screen here for an agent, it's actually quite simple, right? It's not complicated. I don't have multiple slides to explain it. It's fundamentally simple where you have this LLM call there in the middle. That LLM might have access to a system prompt that is battle tested, and they might have access to a series of tools, right? So that can fill in the sort of action piece there. And then you allow it to interface with the environment and run in this loop until the model decides that it's done, right? So the complexity in terms of the architecture is simpler. We're delegating more to the model, and these are often quite powerful, right? And use cases that I think have product market fit, or at least the agents have product market fit, and in terms of this definition, are agentic search, right? Deep research. The research that we built at Anthropic within Claude works fundamentally like this. There's some sub-agents there, but it looks a lot like this if you were to peel back the onion. And then autonomous coding. Claude Code works just like this if you've played with Claude Code. And then computer use as well. If you play with computer use agents, they're fundamentally doing the same thing, except one of the actions is a screenshot tool, and the other actions the model can take are things that you're doing in the graphical user interface. Right? So this is how we think about agents. If we think about agents versus workflows, again, these each have their place. You can compose these together. This is not an all or nothing thing. We just define agents as this open-ended system where you give the model access to a series of tools and allow it to run in a loop until it's done. Right? Models are getting much better at both of these. So as you get more capable models, they're just going to perform better in workflows. Right? They're more intelligent, they're more reliable, they follow instructions better, they're more useful in workflows. They're also getting a lot better, in particular, at this agent loop, right? So calling tools in a loop over a long time horizon to complete some complicated task for you, especially in coding, research, computer use, you're going to see models continue to get really, really good at this. This is very important to us at Anthropic. It's important to the broader community. And I would just keep an eye on this pattern because it's starting to work really well. A huge portion of my team's work over the past 6 to 9 months has been taking components of workflows where our customers were trying to define a lot of complicated steps and replacing some aspect of those workflows with agents where it makes sense. And in a lot of those cases, it's simplified what our customers have had to maintain while also improving performance. So just keep an eye on this. An example agent is a coding agent, right? So I gave you Claude Code as an example, but if we look at an example task from SweBench Verified, this is how this SweBench Verified implementation works. We give the model access to 2 tools. There's an edit tool, and there's a tool that lets the model run bash commands. Those are then executed inside of a VM with the repository. In this case, the individual test case is an issue in scikit-learn. And then we let the model, with a very simple system prompt, run in a loop, and it will think. Maybe it'll use a tool like the string replace tool. This is the edit tool, where it's deciding to make a change to some aspect of the code base or to some file. And it will just continue to do this in this loop until it decides that it's done, right? So in the output, we might have something to the effect of, hey, I did it. Here's a summary of what I did. And if we see that the model's final output, the stop reason was end turn, we will just submit the solution that the model came up with for this task on SweBench, right? So it's quite simple. There's some infra stuff that it was a little bit painful with SweBench, just setting up the VM, things like that. But fundamentally, the agent architecture is simpler than you might think. So let's talk about building agents. What have we learned? There are a few areas I will touch on that I think are like general themes to keep in mind. And I'll go through these one by one. So the first here is reasoning, right? This is going to sound very obvious from the Anthropic guy, but you should choose a model with strong reasoning ability. Right, so something like a Claude 4 Opus or a Claude 4 Sonnet, or just a model that you feel very confident in its reasoning ability, a model that has extended thinking or reasoning capability where it's going to use a scratch pad, or it's been trained to use a scratch pad to think first before doing something. The new Claude models can also think upfront, so they can devise a plan, like in that SweBench example, the model could devise a plan about how it wants to go about this issue, but then these models can also think in between tool calls. This is a new thing. We actually had this sort of hack that we published a blog post about called the think tool that got around this limitation where the model couldn't think in between tool calls. But we just trained the new models to be able to do this natively. That's important because you want the models to be able to reflect over what they're seeing as they're editing a code base or as they're reading things in your code base, right? So you want them to be able to reflect between tool calls. These models can do that. Reasoning models are also better at things like self-correction, right? Self-correction is really important, right? The model's smarter, but it can also course correct if it gets down a rabbit hole that's not making sense. A good example of this is in Claude Plays Pokemon. So you guys might have seen this thing that we produce. This is my friend David, who works also in the Applied AI org at Anthropic, built this. But we actually have some elements in the system prompt for Claude Plays Pokemon that try to help it get unstuck. right? In general, it's good to think about where your agent is going to get unstuck and try to help it troubleshoot, or at least give it some guidelines it can use to troubleshoot. What we did find, though, is that out of the box, the newer models are much, much better at getting out of situations where they were previously stuck, right? So if our Claude in Pokemon is running into a wall over and over again, right, the model is much more likely to be able to course correct and find the right way out, right? It will find the door. Previous versions of the model, like in the Claude 3.5 Sonnet days, would get stuck. They would try the same thing over and over again, and then eventually they would come to the conclusion that something was wrong with the game, and they would start cursing the Pokemon gods instead of actually trying to do the right thing. The models are still, if you go watch this on Twitch, they still love doing some silly things, like Claude loves talking to NPCs in Pokemon, but that's just because Claude's friendly, I guess. I don't know. In terms of eliciting that reasoning, right, it's not enough to just plug a different model in and hope it works, right? You do want to think through the system prompts that you've written. In terms of like some practical concerns here, with Claude models, you should start with the minimum thinking budget, so 2,000 to 4,000 tokens, I think, is a reasonable starting point, and then expand upward from there. You should set constraints, so if you have lots of rules in your prompt, that actually plays pretty nicely with reasoning models. And then you should also consider using thinking frameworks. So you define your own, or if you have some kind of analysis task, like maybe it's some kind of business analysis task or something like that, and you were to say, use Porter's 5 forces, which is something that you might pick up from MBA school or something like that, that will help the model, right? So just keep that in mind, right? If there's some kind of thinking framework that you believe the model probably knows about from its just like pre-training, it's worth asking the model to use that. And then you should consider relying on the model's built-in chain of thought ability over very prescriptive structured chain of thought. So before reasoning models came out, what a lot of our customers did is they would ask the model to think out loud in extremely specific steps, one by one, maybe in JSON or XML. That will still work, right? It's a reasonable thing to do. What we've seen, though, is on net, it's often better to just set a lot of constraints for the model, ask it to think according to certain guidelines, general guidelines, and then let the model do its own set of reasoning that it learned to do during training, right? So keep that in mind. And the final thing, too, is if you have an agent loop that's running, while these models will think between tool calls, and they've been trained to do that, it's still often a good idea to encourage the model to stop and think in between tool calls, especially if it got a lot of information back from a tool call, right? So if you have a coding agent or something like that, and the model has read a ton of files, you want the model to stop and think about what it read before just jumping into some kind of fix or something like that. So that's how to think about eliciting effective reasoning. The other extremely important thing here is tools, right? And this is where some of the Databricks integrations are actually quite interesting that I'll get into in a little bit. But a lot of teams think very, very hard about system prompt design. They think very hard about their agentic architecture. They also think about things like fine-tuning. But what's surprising is that a lot of the folks that I talk to, they don't really think that hard about tool descriptions or tool definitions. I get a lot of one-line, sometimes one or two word tool descriptions to review from our customers. And in general, you want to think about tool descriptions as effectively mini prompts that you need to optimize. So if you were to pop open the hood of Claude Code and take a look at the individual tools in Claude Code, the file edit tool, for example, looks like a standard prompt in terms of its length. It's extremely detailed. It has lots of caveats, lots of rules, some few shot examples in there as well. So really be thoughtful about your tool descriptions, right? These should not just be like one-line things that you'd leave for a human in a comment if you wrote the tool, right? This should be something that's extremely detailed for the agent. You should also consider keeping your tools relatively like scoped down and not nested, right? So if it's possible to split a tool up into 2 separate tools, you should do that rather than having an extremely complicated nested tool with like 9 parameters or something like that. And if your workflows involve file editing of some kind, you should consider using a string replace tool. We actually have an out-of-the-box string replace tool that you could use with a system prompt, not a system prompt, the description we already wrote. Consider using that, or just adopting the pattern of using models to edit files via a string replace method, as opposed to trying to rewrite entire files all the time. Right, so that's thinking through building tools. I'd also be remiss if I didn't mention MCP here. Right, so one of the reasons why we focused on MCP is that we want to bring standardization to the space broadly. MCP is a deep topic. I could probably do multiple hours worth of a talk on MCP. I'm not going to do that today, but you should know that this is an open protocol that enables seamless integration between AI apps and agents and your tools and data sources, right? So just like REST APIs standardized a lot of interactions between backend applications, and the language server protocol standardized how IDEs interact with language-specific tools, MCP is going to standardize, or is standardizing, how AI applications interface with external tools and resources, right? And if I were to go into an enterprise pre-MCP, I would often see a picture that looks like this, a ton of repeat work, right? Lots of fragmentation. Maybe there's an ops team building an integration with some 2003 Oracle database, and then some other team throughout the organization is building the same exact integration, and there's just a ton of repeat work, even within an enterprise, right, let alone the broader developer community. And with MCP, the picture's starting to look a lot more like this, right? You have applications, maybe even internally, like chat applications, right, that are MCP clients, right? There are some third-party applications like Claude or Cursor that are also MCP clients that you can just easily plug MCP servers into. So if one team builds that integration with your legacy database internally, other teams throughout your org can also leverage that same implementation without having to build the integration from scratch themselves. Right, so this is powerful, and the core thing here, again, is if models are getting better and better and better at operating in this tools-in-a-loop pattern, where you give it access to a system prompt, and you give it access to tools with good tool descriptions, what we're going to find is that if MCP makes it really easy to build those tools and plug those tools into models, that just makes agents more powerful, right? And ideally reduces the amount of work you have to do to hook up these external systems. You can also use MCP in Databricks, and you can access lots of tools within Databricks from your Unity catalog, right? This is a code snippet I pulled from the Databricks docs. There's actually a lot of really good documentation on this, but there's a couple different MCP server types you can use in Databricks. One of them is managed MCP servers. So that's stuff out of the box for like vector search, for interfacing with functions that sit in Unity catalog, and then also Genie Space. And then you can also deploy custom MCP servers as well via Databricks apps. And then what you can do is you can either use these servers to build your own custom agents that you develop yourself with like one of the Python SDKs or something like that, or you can take these servers and you can plug them into surface areas like Cursor or Claude.ai. Right? So this is quite a powerful thing to keep in mind, and Databricks is really working hard on making the experience good within Databricks itself. The other thing too is if you don't want to use MCP, there are other options within Databricks to give the model access to tools that just come directly from your Databricks instance. You can use functions that are just from Unity catalog. Right? This is actually really easy to set up. I went in and did this before today's talk. It was super easy. Right? I just went into the Unity catalog, defined a function. It's all managed in Unity catalog using the same permissions and governance features that you already have in place there. So that's quite effective. And you can also create custom agent code functions as well. So if you want to interface with some other REST API and then you want to just deploy this logic somewhere in Databricks, you can also do that. This is a relatively low-lift thing if you just want to interact with a couple of simple REST APIs or something of that nature. Okay, so that's reasoning, that's tools. Let's get into memory. This is an interesting one because memory means a lot of things to a lot of people. What we've started to find is that it's possible that tools and a file system could be all you need for memory. Knowledge graph structures and things like that are interesting, right? Like using vector DBs could be interesting. But we've found via a lot of our own internal work and some of the products that we've built, like Claude Code, just using some kind of file system, markdown files, .text files, whatever file format you want, doesn't really matter as long as it's some kind of text format. This works quite well, right? If you give the model access to a couple of tools that allow it to read and write to a file system as this concept of memory, that can get you quite far, right? And it again leans on the model's continued improvement at this tools-in-a-loop pattern, and I think it's going to be pretty scalable. Right, so as models get better at using tools and reading and writing from files in an agent loop, they're going to get better at using memory in this way. Right? So with Claude Code, we have these Claude.md files. You could just define Claude.md file. What that will do in Claude Code's case is it will just append things to a system prompt. But what we also do with our own Claude Code usage internally, and what I do with Claude Code, is I ask Claude Code to create 3 folders as it's going through and doing something for me in a code base. I'll ask it to create the equivalent of like Asana tickets with new tickets to take on, open tickets, and then close tickets. And that also creates an interesting memory-like structure where the model can go through and actually just keep track of what it's done for me so that as we get closer to running into the context window limits, the model knows that, hey, like it can always look back at these individual folders with my tickets and know what it needs to do next. right? So keep that pattern in mind. I think that's going to continue to work better and better as models get better at these specific patterns. So a couple of tips when it comes to implementing memory. You'll want to do all the standard prompt engineering tools for optimizing, prompt engineering implementation things for optimizing memory tools in the same way you want to optimize any other tool definition. The file format matters less than you think. So if you have markdown files, text files, it doesn't really matter that much. And you want to encourage models to read and write from these memory files quite often, right? So just encourage it to do that, and I think the model will likely be able to do this quite effectively for you. The last thing I'll say is that compaction as a general pattern tends to work really well if you have a very good compaction prompt. So one thing that a lot of people are concerned about is longer and longer context windows. And I think that models will continue to have longer context windows, but what we've found is that for complex tasks where the model needs to run for 30 minutes plus to get something done, it's inevitably going to hit the context window limit. And even if you were to expand the size of the context window, eventually there's going to be some new threshold. As models get better, maybe it's an hour and a half where they hit the limit, but there's always going to be some concept of a limit, right? Or maybe not. We'll see what happens. But you can at least plan for the near future to have some sort of effective limit. And what we found in products like Claude Code is that just automatically compacting via a really, really good summarization prompt allows the model to just pick up, right, when you start anew with a fresh context window with all the context that it needs to still be effective. So if you've used Claude Code and you've had it run for a while for you, if you did the vibe coding thing and you stood up and you got a cup of coffee and then came back after 30 minutes, what the model likely did is it ran some kind of auto compaction step using a tool that it has access to, and that, again, tends to work really well. So I would consider that pattern too if you're concerned about context limits. Okay, so that's some general advice that we've picked up when it comes to actually building agents. I want to just briefly show you how you can spin up agents in Databricks. Again, I did this today. It was quite straightforward. And then I think we might have 10 or so minutes for Q&A if that's a feasible thing. So I think they might have microphones they can run around, if I'm not mistaken. We will see. So let's talk about Claude and Databricks, right? You can access. Let's see here. Looks like my video broke there. So we will show it. We will show it maybe some snippets of it. If you go into the Databricks playground, you can very easily add tools by just clicking on this tools button here. You can play around with various models. There's also nice AI judge functionality here as well, where you can have the model provide its response and then get some kind of automatic judging. The playground's quite good in that it will also suggest new things to ask as well, and you can really start playing around with different models for your given use case. When you click on tools, though, what you'll be able to do is go in this case, this is a Unity catalog define function. You'll be able to go in here and define a function, right? This is a very minimal tool description. I should have followed my own advice and been much more detailed about my tool description there. But what this does is just calculates the average fare by distance using a sample table that sits within Databricks. This is a New York City taxi trips table. And what this will do when the model calls this tool is it will just run this query against data that sits within Databricks, right? So quite straightforward, and you can add lots of these tools if you'd like to. Again, I think I might have some video issues. What you can see there is once you have those tools connected, you can see here at the top of the screen, I have two tools connected. One of them is that average fare by distance tool. And you can see here that I tested it, and the model ran in a loop. It called one tool that calculated the distance between two distances, or two locations, right? So I had the Empire State Building and Hudson Yards in New York, right? So the model was able to call a function and get that distance, and then take the output and call another tool, right, that calculated the actual fare based on that distance. And you can prototype lots of different agentic interactions in here as well, right? The model says that the cost to take a taxi between Hudson Yards and the Empire State Building is $8. That seems a little cheap to me, but nonetheless, this is a great way to prototype things, and I'd encourage you to get started here as well. The last thing you can do there is you can hit Create Agent Notebook, and that will allow you to get all of the code you need to scaffold your agent in a Databricks notebook. And they use like MLflow, LangGraph as well. It's already scaffolded in there for you with the model you selected, so Sonnet 4 will be selected, and all of the tools we defined as well. So everything is like pretty much there, batteries included out of the box. And I'd really encourage you to start here if you're looking to build an agent that pulls from data that sits in Databricks. So I think I will leave you with that. And then I just want to give some parting advice before we do a little bit of Q&A. So the first thing I will say is don't add more complexity than you need, right? So think about whether or not some kind of augmented LLM or workflow will solve your problem, right? I would also avoid reaching for things like multi-agent systems too quickly, right? There's a whole 201 level talk I could give on sub-agents and multi-agent systems, but I'd say in general, if someone is pitching you very hard on multi-agent, ask them what they mean, right? They might just mean that they want you to build workflows or something like that, but in general, like a single agent can get you quite far. So keep that in mind. And then I'd say be very thoughtful about frameworks. So before you choose a framework, try to make sure you understand how that framework works, right? The Databricks Mosaic ML framework is a good place to start. There's an AI agent framework as well that you get out of the box when you create that agent notebook that I just showed you. So start there, but also try to peek under the hood. Understand what the frameworks are doing. That's going to help you a lot when it comes to debugging. And you always want to make sure that you understand what the prompts look like under the hood. Right? The prompts are quite important because that is the thing that the model is going to see in the end. Finally, like when it comes to your trade-offs, it's very important to think through things like latency, cost, and intelligence, and how you value each one. So if latency is extremely important to you, or if cost is extremely important to you, I would probably encourage you to build simpler systems or workflows, because that will allow you to really define all of the steps the model is going to go through. And it could also allow you to keep costs down by easily plugging in smaller models in some portions of the workflow as well. So keep that in mind. And if intelligence is not the most important thing to you, again, it just might be a good idea to use something simpler than an agent. I will say that the final thing I'll give on reliability is that agents in this loop are going to get much more reliable in the coming months to years. Right? Even today, Sonnet 4 and Opus 4 are much more reliable than 3.7 or 3.5 Sonnet were, but there's still a ways to go. If you need maximum reliability and consistency, if you need some kind of certainty, I'd probably steer you more toward workflows and agents for now. And I'd say that because most of the, as an example, most of the customer support deployments I've seen just have a really high bar for reliability. Mistakes are really costly in that environment in a way that maybe they're a little bit less costly in a coding agent loop where you always have a human reviewing PRs and making sure that the agent is staying on track, or even with research agents. But in those environments, workflows have usually been a good fit because there's just a lot of control you can have over the system, and you can really battle test each step of the workflow. So keep all that in mind. If you have any high-level questions, hopefully we have a chance to run mics around in a second. Maybe not. We'll find out. But beyond that, feel free to find me. I will hang out after this talk out in the lobby area. I'm happy to chat. If you're interested in doing applied AI-like work, I'm interested to chat with you. And if you have any questions on agents, hopefully that's a good time to chat through it, or you can reach out to someone from Anthropic, and we can support you on that as well. So thank you all for being here. I hope this was useful.